The modern world has been built on the cheap and plentiful energy provided by fossil fuels. At a time when Western Europe relies more than ever on natural gas, the North Sea bonanza is over and production is on the decline. But the gas men are not sitting idly by. British and Dutch scientists are breaking new ground to squeeze the remaining gas from rock thousands of meters under the seabed.
Keep coming up on the block.
They're building a new generation of state-of-the-art platforms.
It's a very challenging project.
Pioneering innovative drilling technology.
Okay, let's stabilize there at 25.
And battling the remote and hazardous gas fields of the North Sea.
We stopped the whole operation.
But it will be no easy task.
To me, it's like putting a man on the moon.
These are the new North Sea mega rigs. Two modern superstructures have begun their pioneering journeys into the treacherous North Sea to find one of the most valuable resources on the planet, natural gas. Production is on the decline at a time when the UK and Netherlands rely on gas more than any other energy source. Finding new supplies in the North Sea with its turbulent seas and raging gales is a hazardous operation. Now, some forward-thinking gas companies and men like Steve Kemp are pioneering a new generation of slimline platforms.
Most of the easy-to-get-out gas has already been discovered and produced. So what we're now doing is trying to develop the smaller fields or the more difficult fields.
The gas men are gambling on these two platforms to provide the solution. The Dutch-built F3FA is the largest reusable self-installing platform in the world. She's been designed to hoover up the small gas fields that remain. The British-built Ensign platform will be the heart of a technology called fracking that will crack open the ground deep beneath the sea to release gas that has been trapped in solid rock for millions of years. It will be a massive challenge. Vlissingen, the Netherlands. A modern superstructure is taking shape.
That was the key. Design and develop a platform what is able to install quite easily, and as well make sure that if the reservoir is empty, that you could remove it quite easily from A to B.
It will take 1.5 years to build the F3FA, and the entire project will cost over £200 million. But with its prolonged lifespan, the F3FA should more than pay for itself. In the vast hangar in Vlissingen, workers are bashing, screwing and welding like the clappers to bring the idea alive. When completed, the platform will weigh as much as the Eiffel Tower and be as high as the London Eye. The completed platform is designed to sit on 4 enormous legs that will need to slide up and down these enormous brackets. Connecting this iron island to the outside world requires a helideck, but by the time it's been craned into position, the once cavernous hangar is full to the brim. Now comes the tricky bit. Somehow, they've got to get this 4,000-ton mass of steel out of the hangar so that the 80-meter-long legs can be fitted. In the end, they just wheel it out. It just takes a lot of wheels. 240 of them. This is the self-propelled modular transporter, the ultimate way to carry the world's heaviest loads. The 133-meter-high structure will have to be carefully loaded onto a barge in the harbour. Hartlepool, the northeast of England. Workers here are building the Ensign platform. It's the latest in a line of compact and economical gas platforms, specifically designed for smaller gas fields. The daunting task of completing the build on schedule is in the capable hands of construction manager Andy Close.
The Ensign project started construction in August. By the time we sail away, it will be 11 months. From start to steel, cutting and fabricating, to installing offshore.
Towering 50 metres into the sky on the other side of the construction yard is the jacket, a web of pipes that are designed to carry the weight of the Ensign and withstand the power of the North Sea. Calling the shots on this construction is project manager Ken Scott.
It sits in 25 metres of water depth, and in the North Sea everybody knows it's not kind and gentle and it's not exactly the place to be.
The Ensign field has its own unique conditions, so the robust jacket had to be custom designed and built from scratch. The F3FA gas platform has reached the final stage of construction. The 133-metre-high structure has to be carefully loaded onto a barge in the harbour. As the modular transporters inch the F3FA forward, the barge pumps thousands of litres of water out of its ballast tanks. They effectively become metal balloons, keeping the barge afloat and perfectly stable. The barge stays steady, and the final stage of the platform construction can begin. The 4 huge 5-storey high feet that need to be welded to the base of the legs are in fact suction anchors. Upturned buckets, each big enough to hold more than 2.5 million litres of water.
When you arrive on the field, you lower down the 4 legs in parallel, and due to his own weight, penetrate already in the seabed.
It's the final design idea that the engineers hope will make F3FA the largest self-installing platform in the world. Ensign can finally begin her journey. 4 tugs position themselves around the platform to guide her out to sea. The jacket and topside will have to be craned into position, and for the first time the platform will be exposed to the extreme conditions of the North Sea, and its builders will know whether they have succeeded or failed. At Petrofac Training Centre in Aberdeen, all employees who will operate offshore on platforms like the F3FA and Ensign must complete a thorough safety course.
The point of the training is to give everyone a basic understanding of the offshore environment, all the hazards that go along with that environment.
To save lives, platforms like the F3FA are equipped with state-of-the-art free-fall lifeboats, the biggest of which can hold nearly 100 people and launch from up to 50 metres high. Each lifeboat is designed to survive the most powerful North Sea storms.
Well, I hope for everyone that comes through here that they never have to use this in a real-life situation, but if they did, they will be prepared for it and they'll know what to do, and it could save many lives.
After a 36-hour, 150-kilometre journey, 2 tugs pull the Ensign up to its final destination. Construction manager Andy Close and his boss Chris Bird have flown in to oversee the installation.
The platform, it's actually got 3 wells, potentially can drill 3 wells into it. So what we've done is drilled 1 well under where the platform's going to go already. So that's already been drilled and completed and tested. And then we're drilling another well at the moment, which is from we call a jack-up drilling rig.
The sky is clear, the sea is calm. It's a perfect day for a platform installation. The mighty crane takes the strain and begins to lift the 750-ton jacket off the barge. All the planning now rests in the hands of the crane operator. Ever so slowly, the jacket is swung out over the sea and lowered beneath the waves. A quick correction and a small spin, and the jacket gently sinks towards the sea floor. Touchdown. It's a huge relief. But as the sun begins to set, there's no time to relax. The first priority is to secure the jacket to the seabed. 4 65-metre-long, 75-ton steel tubes, known as piles, will be hammered through the jacket's feet and into the ground.
It's a bit like driving a great big tent peg into the ground and then filling it up with cement to make it rigid.
Under the glare of spotlights, the crew beaver away through the night, burying the piles. By daybreak, the last pile is almost finished. But a new day has also brought a new problem.
As you can see outside, the weather's closing in rapidly. He had to let the barge go to sail into safe harbour. So that's now heading off to the Humber estuary, where it'll be held till the weather abates and we get a good forecast.
The Ensign platform heads back to port, and the crew are forced to wave goodbye to their schedule. The North Sea, 200 kilometres from the Netherlands. A severe environment near the Dogger Bank. It's in this inhospitable location that engineers plan to anchor the F3FA gas platform to the sea floor, 40 metres below the surface. The F3FA will have to spend years being pounded by the North Sea weather, so anchoring the legs firmly to the seabed is imperative. Permanent platforms are often fastened using giant pegs, which are hammered into the ground and then concreted. This wasn't an option for the F3FA. Instead, they decided to use enormous suction cans. Once they're in place, huge pumps suck the water from within the buckets and the pressure pushes them further into the seabed. As the sun sets on the second day, the F3FA platform is firmly embedded in its new home. When the base of the platform is 10 metres above the waves, the F3FA platform is locked into position and the barge can slide out from beneath her. The whole process has taken just 2 days and 4 hours, a record time. "80 kilometres off the coast of England, the Ensign platform installation has suffered a major setback.
So as you can see, it's quite windy outside here. That's why we stopped the whole operation. We are so-called waiting on weather.
The barge will return in just under 24 hours. It's going to be a long night for the crew.
The weather's now starting to drop. If it goes to plan, we should be lifting on Thursday afternoon, back on target to be able to complete and get off for the weekend.
Right on time, the barge bearing the Ensign topside sails into view. The weather is holding, but they can't afford to delay. The platform will have to be installed at night. The lift is an incredibly precise operation, positioning a massive hunk of steel on a frame with only millimetres to spare. With the weight of the platform hanging over his head, a crewman makes sure the topside is perfectly lined up with the jacket. With pinpoint accuracy, the guide cones slip into the jacket termination points. And then a heart-in-the-mouth moment when, for the first time, the jacket takes the weight. By the morning, their work is nearly done. But for the Ensign platform, it's just the beginning. 400 metres north, an operation is underway to drill down into a seam of solid sandstone, kilometres beneath the sea. And to release the gas, engineers will have to conduct the biggest subsea fracking operation the North Sea has ever seen. Knowing where and how deep to drill is in the hands of the geologists. In Aberdeen, on Scotland's northeast coast, geologists are using both high and low-tech methods to hunt down gas deposits in the North Sea.
So this cliff section behind me is a big thick section of sandstone, and this sandstone got buried down to quite a deep depth, about 3 or 4 kilometres deep. And at that depth, gas gets generated and migrates into sandstone like this, which gets trapped as a reservoir, which we can then drill into and flow the gas out of.
The next challenge facing the geologists was to find these dense sandstone formations deep beneath the sea. To do this, they simply had to listen for them, which may sound strange, but it's exactly what happens in a seismic survey.
Seismic is essentially a way of recording sound waves that penetrate through the Earth, and how they reflect back up gives us an idea about variations in the rocks and also whether there are accumulations of gas, oil or water.
But first they need to drill a well, 5 kilometres long, deep into the Earth's crust. And for that, they'll need some heavyweight help. The 15,000-ton jack-up drilling rig, Noble Julie Robertson, is a well-travelled machine. Built in Singapore, she has been drilling wells around the world since the 1980s and helped build the Channel Tunnel. 60 days ago, she was towed into position, 400 metres from the Ensign platform, under the command of drilling supervisor John Knowles.
The Julie Robertson is a jack-up rig. On each corner there's a leg, and the rig itself can lift up so it floats along as if it was a boat. We lower the legs to seabed, and from that point then the rig actually lifts itself up.
The drill is like a giant domestic drill with an enormously long shaft known as the drill string that is constructed from 9-metre-long lengths of pipe. Just like a domestic drill, picking the right bit is a vital decision. Choose the wrong one and the drilling will slow down, or even worse, the bit can break. When they cost hundreds of thousands of pounds, you don't want to make a bad choice. These tungsten carbide teeth are 3 times tougher than steel, but the drill still has to be checked or replaced at regular intervals. This bit has worn down badly. Much more use, and it could have broken down the well. With a new bit in place, the epic drilling mission continues.
It's a success. If we drill a hole to 17,000 feet, we've gone through all this, all the equipment, and we haven't hurt anybody.
The Norwegian-built 3,000-ton Big Orange 18 is steaming into IJmuiden harbour in the Netherlands. She's one of 2 ships that hold the key to the Ensign project's success. Because encased inside the hull of this powerhouse of a ship is the technology to crack open hundreds of metres of solid sandstone and let the precious gas flow out. Splitting rock takes an enormous amount of force. But Mark Norris and his team don't use high explosives. They use a liquid.
Well, hydraulic fracturing is a process where we pump into a well, into the formation at the bottom of a well in very, very high pressures and rates to literally split the rock either side of the well for many hundreds of feet.
But the problem is, once you've cracked open the rock, how do you keep it open?
While that split, or fracture as we call it, is still open, we introduce and pump into it tiny little hard beads. And when we stop pumping, instead of the fracture trying to close, it can't, and it closes on these hard beads. These beads are called proppant, and they prop the fracture open, keeping it open.
10 seconds to shut down.
Five, 4, 3, 2, 1. Shut down pumps.
Initial readings indicate that it was the perfect frac.
Frac length's what we were looking for, so that's the one we're playing.
But they won't be sure until the gas begins to flow. Vigra, the west coast of Norway. To lay kilometre-long lengths of steel pipeline in the middle of the sea is a complex engineering challenge. Pipelines are assembled at this onshore facility and spooled onto giant reels, mounted onto specially designed ships like the Seven Navica.
Seven Navica was built in 1999. She's 109 metres long. The big reel you see behind me, the main reel, It stands 25 meters high, which is about equivalent to a 5-story building.
This fabrication shed has 25 workstations that will mate the pipes together to produce a 1,500 metre length known as a stalk. In a few weeks, Ensign will be hooked up to the well and gas production will begin. The gas will journey down the hundreds of thousands of kilometres of pipeline, transporting it from deep beneath the sea to terminals like Barrow on the coast. Here the gas is purified before it's pumped out to power stations and our towns and cities. The F3FA is already piping gas to the Netherlands.
So the F3FA field is a gas condensate field. We've got approximately 3 BCM, billion cubic metres of gas, and we're producing about 1.5 million cubic metres of gas a day. Unlike many of the older vessels in the North Sea, this installation has been designed to be manned by a minimal crew, so the entire installation is controlled by 8 people. Typically they work 2 weeks on, and then they have 3 weeks at home, and then they return back to the platform again.
Some people think that North Sea gas is running out, but the hunt for gas will continue.
So I can see within the North Sea, not just the UK, but if you take Norway, across Denmark, Belgium and into Holland, there are sufficient reserves out there in terms of gas to last us for decades to come.
We all look at the Ensign development and the F3FA development that came on this year with great pride. I'm really proud of what our team has achieved, and it's come with a phenomenal amount of effort. It's not been easy, both to overcome the technical challenges, but also some of the commercial challenges that came with it as well. We bought fields that others thought, what on earth are you doing here? We've not managed to unlock them, and quite happy to be rid of them. And we've, developed them into something that everyone in our business, I think, should be, hugely proud of. And it builds confidence in what we can do. It allows us to go on and do more things with the business. It allows us to go back for more investment and say, we've got a track record, we can develop these things, we can make a difference, and take that capital and do more with it.
The future of North Sea gas rests upon these multi-million-pound superstructures and the pioneers that build and install them.